Numbers. Alright, on page 348. Square numbers. Certain numbers. We learned about prime numbers, we learned about composite numbers, we have some numbers that can be called square numbers. Now what is a square? How do you know something's a square? Not perfect, but we'll pretend that's a square. Okay? If this really was a square, how would we know it's a square, Stephanie?
Because it has 4 straight lines.
Not just that they're 4 straight lines.
It's a square, and everybody knows what a square is in kindergarten.
Because we just look at it, we know it's just because it's a
Because
square,
you
right?
learn it's a square.
Yeah, but you know what? When you get into, I think, 10th grade, and you take geometry, you will have to actually write out something called proofs, and you'll have to actually prove that it's a square. You're actually going to have to explain. That's not till 10th grade, don't worry about that, okay? But you will actually have to be able to prove that it's a square. I know, you're thinking, well done, of course it's a square. But how do you know it's a square? And not just because you look at it. I mean, you looked at it in kindergarten, and you knew that it was a square. You probably knew it before that. But there was something about this that makes it different than this. There's something that's different about it. What makes it a square, Karis?
It's 4 tiny straight lines.
4 tiny straight lines? So,
That's not tiny.
is this not a square?
That's a square. It's not connected.
Sure it's a square, okay? If I was a very good artist, that would be a square. But a square could be big. What makes it a square, Joseph?
It has 4 sides.
It has 4 sides. What makes it different than that? Cadence.
All 4 sides are equal.
All 4 sides are the same. All 4 sides are equal, okay? They're all the same size, okay? Now, that's going to help us know about square numbers. Some numbers are square also, all right? Look at your lesson, okay? A square number is a number that is the product of any number and itself. So, let's say it this way. If I had just this one square, okay, and I said 1 times 1 equals, everyone, 1. 1 times 1 equals 1, all right? I multiplied a number by itself to get my answer, and I got my answer, and so that's a square number. But what about this? What about this? What if I had, okay, we'll pretend these are perfect squares, okay? You have to do a lot of pretending in Mr. Yu Jaws, okay? All right, so now I have how many squares? Everyone? 4. Okay. How many squares do I have going this way?
2.
How many squares do I have going this way? 2. 2 times 2 is 4. So 4 is a square number because I took the same number and multiplied it times itself to get my answer. So 4 is a square number. How about this? How about this? Again, we're pretending. Pretending these are all the same size too. We're also pretending that they're all the same size. That's, we'll use our imaginations here. Okay. All right. So now, how many squares do I have going this way?
3.
How many squares do I have going this way?
3.
How many squares do I have total?
6. 9.
9. Okay. 3 times 3 is 9. 9 is a square number because I multiplied one number by itself to get 9. Okay? What do you suppose my next square number would be? Anyone want to take a guess? Take a guess at what my next square number would be? What would it be, Owen?
16.
16. Why, Owen?
Because 4 times 4 is 16.
Because 4 times 4 is 16. What would my next square number be? What would my next square number be? Okay? Yes.
18.
Not 18.
Not 18.
No, you're adding on 9.
Yeah.
What you're doing. 4 times 4 gives me 16, and that was my square number. What would my square number be after that?
My brain does not want to work right now.
Okay, that's alright. Yes?
Maybe 9 times 9?
Not 9 times 9. No, not 9 times 9. Anna Grace? Oh, Anna Grace found it on the page. That's perfect. That's good. Good thinking. It helps to look at the page sometimes. Okay? But why, Anna Grace? Why is 25 the next square number? We had 1 times 1, 2 times 2, 3 times 3, 4 times 4,
5 times.
and 5 times 5 is 25. 25 is a square number. Okay? And you can see on your multiplication table there, hands down, you can see on your multiplication table there how the square numbers all go diagonally on your multiplication table. Okay? Because I could do that with all these. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, going all the way down diagonally, and I can find all my square numbers that way. Alright? Now, that's square numbers. But if I asked you for the square root, I'm kind of doing the opposite. Okay? Now, hands down, now I'm not saying what numbers can you get when you multiply a number times itself. Now I'm saying look at the number and tell me what number you multiply times itself to get that. Now I'm saying, let's say 4. Okay? Let's go back to 4. Okay? Now I'm saying what numbers do I multiply, or what number do I multiply times itself to get 4? And you say, raise your hand and tell me, or just shout it out, let's go 2. 2 times 2 is 4. And if I had, go back to this, okay, all beautiful squares. Mrs. Wright would be proud, wouldn't she? Okay. If I say, what is the square root of 9, raise your hand and tell me. Raise your hand and tell me, Delilah. 3. 3 times 3. But you would just say 3. The square root of 9 is 3. Alright, you're telling me what number do you multiply times itself to get that number. So that's square root. You can use that multiplication table to find that. Okay? You can look for the number. So I can look at my multiplication table here. I could, if I said, what is the square root of 81? Okay? If I said, what is the square root of 81? You would go up, all the way up, and you'd find 9. You'd go all the way over, and you'd find 9. Okay? So the square root of 81 is, everyone? 9. You can use that multiplication table to do that. Alright? Alright. Question. Joseph.
Oh, no, never mind.
Okay, Cash?
Can it be a quote?
Can it be a quote?
Like, no, a comment.
Okay, go ahead.
Okay, so, while you were teaching that, this isn't the same thing, but I was here, and I was looking at this. Look, it keeps going like this.
Yeah, exactly. Exactly. Very good. Because if you look, you just take one step down and go either way. That's why it makes a diagonal pattern down across the table. All right. So let's look at number 2 on the lesson practice there. All right. Look at the array there. Okay. Question, Joseph?
Yes.
Okay. Yes.